In this video, we're going to go through some questions on sinusoidal modelling. What can be modelled with trigonometric functions? Well, anything that oscillates, fluctuates periodically, can be modelled using a trigonometric function. Normally, some transformation of the sine or cosine function. Examples include capital D with respect to t is the depth of water at the shore, t hours after midnight. Capital T with respect to D is the temperature of a city, D days after the 1st of January. Capital H with respect to T is vertical height above ground of a person, T seconds after entering a Ferris wheel. Some things you need to notice are that the x-axis will not always contain an angle. In the above examples, time or number of days would be on the x-axis and depth of water, temperature or vertical height would be on the y-axis. Let's go through a typical real-life example. A particle is travelling horizontally while moving in and out of a body of water at a constant speed. The particle reaches a maximum height of 1.3 meters above the water level and a depth of 2.6 meters. The particle starts at depth of 13/8 meters and takes 4/3 pi seconds to move up through the water, reach the maximum height, dive to the minimum depth, and return to its starting point. Write down a model for the height, h meters, of the particle relative to water level at a time t seconds in the form of h is equal to a sine brackets bt plus c plus d, where a, b, c and d are constants to be found. Let's find the values of A, B, C and D. So A is the amplitude, which is found using max minus min divided by 2. So A is equal, so the maximum height is 1.3 minus, well, the minimum height is minus 2.6 divided by 2. So A is equal to 1.95 meters. B, well, that is part of the period, so we know that period is equal to 2 pi over B. So we have period is 4 pi over 3, and that's equal to 2 pi over B. So if we rearrange that, we get B is equal to 2 pi over 4 pi over 3, which is equal to 2 pi times 3 over 4 pi. And if we work that out, we get B is equal to 3 over 2. So D, well, that represents the principal axes, and that is found by max plus min over 2. So D is equal to 1.3 plus minus 2.6 over 2. So D is equal to 0.65. I've left C till the end because it's the most difficult to find. Right, C represents the horizontal shift, and we know that at the beginning the height is minus 13/8 when t is equal to 0. So we can put all that into our equation. So we get minus 13/8 is equal to 1.95 sine, open brackets, 3/2. Well, we know that t is 0, plus c minus 0.65. So we get, rearrange, we get c is equal to sine to the minus 1 minus a half. Well, we know that that is c is equal to minus pi over 6. That means we can now construct our formula. If we move everything up, we can get that h therefore we get that h is equal to 1.95 sine 3t over 2 minus pi over 6 minus 0.65. And if you draw the function in Desmos, this is what you will get. Another typical type of question is to model tidal flow. At low tide, the depth of water in a harbour is 3 meters. At high tide, 8 hours later, the depth is 9.4 meters. Find a trigonometric function that models the depth of the water d in the harbour t hours after low tide. So if we draw ourselves a little diagram, let's start with, we know that low tide is 3 meters. So if we draw a line for 3 meters, and high tide is 9.4 meters, and it reaches high tide after 8 hours, so it will finish back at low tide after 16 hours. So we get a graph that will look something. So that's high tide. We'll go up and then back down to low tide. So that is the diagram of our tidal flow model. And as you can see, it looks very like a cosine function, but upside down. So that would make it a minus cos function. So our function that we're going to model will be the depth with respect to t is equal to a cos b x plus c plus d. Let's work out the values of a, b, c and d. So a is equal to the maximum minus the minimum divided by 2, which is equal to 9.4 minus 3 over 2, which is equal to 6.4 divided by 2, which would give us 3.2. We know that the period is 16, so we know that 16 is equal to 2 pi over b. Therefore, rearrange it, we get b is equal to 2 pi over 16, which is equal to pi over 8. Let's go back to a. Because the cos function is upside down, a is going to be negative, so that makes it minus 3.2. C, no horizontal shift. Therefore, C is equal to 0. And now let's find D. D is found by the maximum plus the minimum over 2, which is equal to 9.4 plus 3 over 2, which is equal to 12.4 over 2, which is equal to 6.2. So now we have all our values for A, B, C, and D. We can write down our function for our graph. So our initial function should be written as D with respect to t is equal to A cos B x plus c plus d. If we now substitute in, we get d with respect to t is equal to minus 3.2 cos. B is pi over 8. C is 0, so it's pi over 8x plus 6.2. If you use Desmos and draw the following function, you will get, which clearly shows that the high tide occurs after 8 hours and reaches 9.4. Low tide is at 3 at the beginning and at the end after 16 hours.